Soil degradation represents one of the most severe and accelerating global environmental crises directly linked to unsustainable agricultural practices. As the foundational medium that sustains terrestrial plant life, soil is not merely an inert substrate. It is a complex, dynamic, and living system that hosts billions of organisms, stores carbon, regulates hydrological processes, and supports food production systems. Yet, poor land stewardship and agricultural intensification have led to widespread soil erosion, nutrient depletion, and irreversible loss of arable land. This module unpacks the multifaceted dimensions of soil degradation by analyzing scientific, technical, environmental, economic, and sociopolitical perspectives. It emphasizes how modern farming systems and land use decisions drive the rapid decline in soil quality and quantity, affecting food security, climate stability, and ecological balance. Scientific understanding of soil systems. 1. Soil as a living system. Healthy soils are characterized by a balance of physical, chemical, and biological properties. These include soil structure, aggregation, and porosity. Soil texture, sand, silt, clay proportions, water holding capacity, and infiltration rates. Cation exchange capacity, CEC, soil organic matter, SOM, soil biodiversity, bacteria, fungi, arthropods, nematodes, pH balance, and nutrient cycling. A disruption in any of these components leads to a breakdown in soil functionality, with severe implications for crop productivity and environmental sustainability. Types and mechanisms of soil degradation. 1. Soil erosion. Water erosion, sheet, rill, and gully erosion, accelerated by deforestation, poor cover cropping, and slope mismanagement. Wind erosion occurs in arid zones due to lack of vegetation, particularly in desert fringe agricultural zones. 2. Nutrient depletion. Continuous cropping without replenishment, especially in smallholder farms, leads to macronutrient, NPK, and micronutrient, Fe, Zn, B, Mn, deficiencies. 3. Soil compaction. Results from repeated tillage and heavy machinery use, which reduces porosity, impedes root penetration, and leads to waterlogging or runoff. 4. Salinization and sodification. In dry regions, poor irrigation and insufficient drainage lead to the accumulation of soluble salts, damaging root systems and altering pH levels. 5. Acidification. Excessive use of nitrogen-based fertilizers and acid rain leads to a drop in soil pH, inhibiting microbial activity and nutrient availability. 6th, organic matter depletion. The loss of humus, crop residue burning, and chemical overuse degrade soil carbon pools, which are vital for microbial health, water retention, and nutrient buffering. 7. Soil contamination. Agrochemical runoff. Herbicides, insecticides, fungicides introduces xenobiotics and heavy metals into soils, disrupting microbial balances and leaching into groundwater. Global trends and assessments. According to the FAO Global Soil Partnership, over 33% of global soils are moderately to severely degraded. The UNCCD estimates that land degradation affects 3.2 billion people. Regional hotspots include Sub-Saharan Africa, nutrient mining and deforestation; South Asia, waterlogging and salinity in irrigated zones; Latin America, slash and burn practices in tropical rainforests; Central Asia, wind erosion and desertification from mismanaged pastures; global frameworks such as the Voluntary Guidelines for Sustainable Soil Management, VGSSM, the Land Degradation Neutrality, LDN, Initiative, and IBI's Land Degradation Reports provide action plans and indicators for mitigation. Agricultural drivers of soil degradation. 1. Monoculture reduces biodiversity and depletes specific nutrients. 2. Tillage exposes soils to erosion, reduces organic content, and disrupts microbial ecology. 3. Agrochemical dependence leads to soil toxicity, acidification, and loss of soil fauna. 4. Overgrazing strips vegetation cover and compacts surface soil layers. 5. Poor irrigation practices cause salinization, sodicity, and waterlogging. 6. Crop residue removal or burning eliminates sources of organic matter and shelter for beneficial organisms. Solutions and sustainable practices. 1. Conservation agriculture, CA. Minimum soil disturbance, no-till or low-till. Permanent soil cover, mulching, crop residues, diverse crop rotations. Result, restored soil structure, higher SOM, improved infiltration, enhanced microbial activity. 2. Organic amendments. Application of compost, manure, and biochar to restore nutrient and carbon content. 3. Agroforestry systems. Integration of trees and shrubs on farmlands for erosion control and organic matter buildup. 4. Terracing, contour plowing, and strip cropping for sloped lands and erosion-prone zones. 5. Soil testing and balanced fertilization. Site-specific nutrient management, SSNM. 6. Cover crops and green manure. Prevent erosion, suppress weeds, and improve soil nitrogen via legumes. 7. Policy interventions. Land tenure security, farmer training, and incentives for soil conservation practices. In summary, soil degradation is a silent crisis that undermines food production and ecosystem stability. Unsustainable agricultural practices are both a cause and consequence of soil degradation. Solutions exist, but require a systems-based, integrated approach combining traditional knowledge, scientific methods, and effective policy. Restoring and conserving soil health is a key strategy in achieving climate resilience and sustainable development goals, SDGs, especially SDG 2, Zero Hunger, SDG 13, Climate Action, and SDG 15, Life on Land.